oops. I'm going to now start start demonstration of two tools that we use for model mapping. We just talked some about model mapping in the three different traditions. I'm going to show you a way that you can conduct model mapping first in AnyLogic, and then we'll show you a tool that we've been evolving and that even over the course of the week will be further evolving to support model mapping. So if anyone has AnyLogic up, I'd ask that you switch to it and that you go to the File menu and close the current model in AnyLogic. We will start a new model. Okay. And we are going to draw out, using a causal loop diagram, a simple causal loop diagram. It's my hope to have it up in the on the screen here, but I may not be able to do that. So here we go. Okay, so here we go. This poverty and substance abuse, we're going to begin the first part of that within this diagram. To do that in AnyLogic, we're going to do File, New, Model, and we're going to say poverty causal loop diagram, CLD. How did I do that? I went to AnyLogic, I said New Model, and I said poverty CLD. And I'm going to choose, time units aren't really relevant here because it's not a dynamic model, but it's always good in general with AnyLogic models to be a little bit careful about what your time unit assumptions are. After all, if you're simulating the behavior of mule deer, you probably do not want seconds as your time unit, except perhaps to simulate the details of their pawing behavior. Okay, and we're going to do finish, and AnyLogic will then create a model for us. This is our first model, so I hope to approach it with a measure of pride. This is our first model here. And you'll notice it comes up, it shows us a palette as well as the model itself. All we'll be doing is in main going and placing some items on this and linking them up in a causal loop diagram sort of way. So to best do this, you go to the palette and you can go to the System Dynamics palette here. System Dynamics palette is one that is visible with this sort of little loop. To me, it looks uncomfortably like a bomb, but it's some sort of loop here. And we're going to, you notice that within System Dynamics, there's a bunch of things we can add. We're going to confine ourselves to a small numbers of these now. Specifically, we're going to make use of dynamic variable and link, which use sort of more generic shapes. So dragging in a dynamic variable to this palette, I'm going to start showing this diagram. And the first thing I'm going to draw is substance abuse here, okay? So I just drag this in, and you can either immediately start typing, or you can go over here and type. And the unfortunate thing about doing it in AnyLogic, that is a feature that does not encumber our platform, is that you have to make things a single word. And what that means is we often put underbars between things, or we will engage in what is called camel case, which is abbreviating or putting with capital letters successive words. So I'm going to say substance underbar abuse here, okay, as the name of this term, okay. Now, having drawn that in here, I can position it as I see fit, And I'm going to drag another one in here, stigmatization. These diagrams are often helpful for articulating theories, some of which might be involve things that are a little bit fuzzier or less observable, but which we're convinced are likely important. And stigmatization, I think, is one of those things. It probably could be quantified. Here we're dealing with it as a somewhat more general concept. So I just dragged in, again, dynamic variable and called it stigmatization. If you drag it in, you can immediately start typing its name right here, or if you don't do that, you can go over to the properties window and change its name over in the properties window. And I'm going to add in one more variable along that causal pathway, which is called employability. Okay? Employability. Now, we're dealing here with pieces, but the key thing, as Jeff noted, in his normal insightful fashion, is to have the connections between them, the links between them. And here, to put in the requisite links, I'm going to use this link item from the palette. Okay? And I'm dragging in a link, and links will play an important role in this boot camp. So I'd ask you to, and particularly the semantics of how we connect them is important. So I'd like you to pay attention to this. When we drag a link in, try to make sure that it's actually docked with the variable. You'll notice if you just drag it in, it's got these kind of white circles on either end. But if you hitch it up to a variable, it actually turns green. Ladies and gentlemen, green is the color. And causal loop diagramming is the game. So you can drag this both sides so they hitch up to the variables here, okay? And you want to make sure they're docked. And the fact that they're linked in, that they're appropriately connected, means that if you drag around something, it will drag the connection with it, which is a virtue that recommends that. Now, drawing the connection does not by itself associate it with a polarity. In order to do that, you'll want to go you want to select this thing here, this link, and you'll want to indicate a polarity. It could be a plus polarity. It could be a minus polarity. Now, there was a good question. Could a polarity be a plus or minus? And there are cases where, under situations of, say, managerial decision-making, you're not sure if it's a plus or minus, and you want to associate it with an uncertainty. So you might use a question mark, for example, and then you have a question mark associated with its polarity. But I would caution you that when we have this sort of situation where we're not sure of a polarity, often it indicates that we haven't really fully mapped out the requisite components. So let's take a case, and I'll make this full screen so we can see this in greater clarity. So when we have an ambiguous link, something that sometimes seems plus, sometimes minus, you really want to think about what is it that causes us to be unknown. Often, but not always, it is associated with multiple pathways between these things. So let's, in intervening mediating variables. So if we're dealing with, say, something like overtime and work accomplished per day, you might say, well, there are times where overtime increases the work accomplished per day. Sometimes it lessens it. I'm not really clear about that. But if you further explicate different pathways, you've got overtime leading to fatigue, which lowers efficiency, and which then impacts work accomplished per day. And if you think about that pathway, to figure out its polarity, the rule for figuring out polarity associated with a pathway, including one that's in a loop, is to multiply the signs by the rule of signs. So we have a plus times, so let's derive each of these lengths, the plus. So if we increase over time, other than things being equal, fatigue will increase compared to the value it otherwise would have had, all other things being equal. So this is a plus length. If overtime goes down, fatigue will go down. If overtime goes up, fatigue will go up compared to the value it otherwise would have had, all other things being equal. So that's a plus length. Some people indicate that with an S for same. And there's actually a little bit of a tempest in a teapot in the system dynamics literature with characteristically flared emotions about whether you should use S's or O's and versus pluses and minuses. Similarly, between fatigue and efficiency, let's think through the link there. As fatigue goes up, all of the things being equal, does efficiency go up or down? If fatigue goes up, does efficiency go up or down? Goes down. So it's associated with a negative link, meaning that it changes in the opposite direction. Similarly, if fatigue goes down, efficiency goes up. So we give that a negative polarity for that particular link. And then a link between efficiency and work accomplished per day. As efficiency goes up, does work accomplished per day go up or down compared to the value it otherwise would have had, all other things being equal? Up, yeah. So it's a plus polarity. Now let's think through the polarity associated with the whole causal pathway, from overtime to work accomplished per day. As overtime goes up, I'm thinking through the whole pathway now. So bear in mind that our thinking through the whole pathway involves reasoning about the subsequent changes all along the way. As overtime goes up, fatigue will tend to go up. As fatigue tends to go up, efficiency goes down. As efficiency goes down, work accomplished per day will tend to go down. Right. So, and what that means is if overtime goes up, through that pathway, work accomplished per day will go down through this pathway of fatigue. By contrast, overtime can work through another pathway additionally with more time working, which leads, all of the things being equal, compared to the value otherwise would have had, more work accomplished per day. So if we if we hold constant these other effects, it leads through this pathway, it's more work accomplished, and these two pathways compete for influence on the work accomplished per day. There's some fascinating studies looking at the effects of that. But the end point of this is that if we just link overtime directly to work accomplished per day, it's a quite blunt or quite aggregated sort of relationship. We're obscuring the fact that there's multiple pathways in the way, some of which make it sometimes positive and sometimes negative. And in fact, I would argue that there's a delay associated with this one, with fatigue, that software engineers know all too well, in this very floor, in this very room, where fatigue builds up over time. And what that means is, if you just try to represent it in a very sort of aggregated way, overtime and work accomplished per day, you'll be confused. Is it positive or negative? That's a hint. It's whispering at you, try to disaggregate into multiple pathways, okay? So when you have a question mark in your mind about the length, question yourself, would it help to disaggregate it into multiple pathways? You'll notice there's another negative pathway through the fact that when we work overtime, we tend to bring more personal things into work, because after all, we're there. We got to do some personal things at work that otherwise we could do at home after going home from work, and that tends to lower efficiency as well. So if you have those competing effects that may change the link, consider disaggregating into multiple pathways, okay? It's a hint. You should think about that. There are times where, because of managerial factors or what have you, you're not sure how it reacts, but Often it's a hint that you haven't explicated things quite enough in terms of the pathways. Okay, I'm going to link up now stigmatization with employment and employability. Stigmatization, all other things being equal, does it tend to, if stigmatization goes up, will it tend to lower or increase employability? Okay, so it's associated with what sort of link? Negative link. There's learning. Good. You'll notice you can also put a delay indicator, that's these double bars, which indicates relative to the other links depicted, this link has some delayed effect. There's a delay associated with it coming into effect. It takes time to build up or what have you, or to feel that. Okay, so this is using any logic to draw these links, a powerful tool indeed, and one that is recommended by additional flexibility. We can, for example, make use of something called a system structure diagram, where we additionally have stalks and flows. So, for example, we might represent a stalk associated here with health, or with dysphoria and stress, and health built up and health decays over time. And so we may think about some measure of health and treat it like a stalk, and we can actually use these sort of tools to represent health as a stalk and clarify the fact that certain things are flows that build up that stalk or drain that stalk. Similarly with things like the wealth or dysphoria and stress. There's things that might build it up and things that deplete it. Activities that are stress releasing. So one of the advantages AnyLogic has is we can weave in components from multiple types of modeling, which is attractive. Another thing that we can do is we can make use here within this palette. The presentation palette offers the ability to drag in an image. And sometimes by dragging in an image, we can make our diagram a little bit more understandable. And so I can go and insert an image, which is in this case less of a germane one. But by inserting an image, I could weave it into the kind of narrative of this diagram if I wanted to do so, which is nice. I might bring in an image that consists of a silhouette or what have you, or some network, a depiction of a network, etc., which is nice. AnyLogic is recommended as a tool for creating these qualitative diagrams. You can't run them. They're not specified with enough precision enough. They can't be operationalized to the level needed to run them, but they can be used to illustrate, and they're powerful as such. So that's one tool I would recommend for this purpose. Another tool is available online, and this is a tool that Jeff has contributed very substantially, and it's a tool called InsightMaker.com. And if you browse to InsightMaker, you will find that, like AnyLogic, it's a fully functional simulation tool, but it also excels at drawing qualitative diagrams. And if you go to InsightMaker.com and you go to Explore Insights, you will find that there's a whole set of community contributions on Insights. And one of them that beckons to us is this healthcare insight, this set of insights. So if we go and we look at healthcare, you will find a wide set of these contributions. Some of them are I see most of those that lie before us come from people in the room, including Roberto and including Jeff. So Jeff has been particularly prolific in contributing some of these insights. And let me get AnyLogic out of the way. AnyLogic for Linux is encumbered by some issues. So Jeff has contributed immeasurable numbers of these diagrams, which are illustrated with a remarkable set of these emoticons and little visual snippets, many of which are evocative and powerful. Wow, that's all I can say. The consumer incentives are particularly powerful icon there. But one of the more interesting things about this is that these can be expanded for many cases. So there are sort of notes on each of these, and some of the diagrams are recommended by the ability to double click on these and expand them, I think. And Jeff, can you suggest any that I browse to at the moment?
I think the other one is to just do the depression one.
Okay, is it?
It's up, go. It's the second one. Yeah, it usually comes up first. Depression dynamics.
And oh, this one here.
Yeah.
Okay.
I don't think that's got any. It's more a CLD up front.
Yeah. Okay.
I'll get a folder after this, but this is just showing you unfolding.
Okay.
You
Great.
click on the step forward on the right bottom.
Okay, over down here. You step forward, and you can do storytelling almost with this. You can explicate it in an unfolding way associated with sort of a broadened set of understanding associated with the model, and often this is accompanied by a narrative in person that helps people walk through the reasoning behind your model, behind your reasoning about the system. So we can add in additional features here in a successive way. And you'll notice that there are these, once again, evocative icons which help us to understand some of the dynamics. Does anyone want to guess what this snowball represents?
Reinforcing?
Yeah, reinforcing feedback. Feedback with the more it goes, the more snow it builds up, the bigger its surface area, and the faster it acquires snow. A phenomenon that is not unfamiliar in these parts, although we lack great hills on which to roll down the snow, except in a few designated areas of the built environment. So we can add in successive components, and you'll notice that there's also successive sort of running commentary provided, which can help people understand elements of these models. So here it's going from the smaller to the broader, linking in with things like relationship quality, physical health, economic status, but also to these very specific models associated with the HPA axis, the sympathetic areas of the nervous system, which regulate stress responses, toxic stress buildup, as well as the not I think represented here as much as the parasympathetic responses of relaxation. So this depression dynamics is illustrative of this kind of successive unfolding. The exit story. Here we go. Great. And this is the full model. Is that right, Joe?
Yeah.
In some of these models, as I said, there'll be further further little bits of information about particular subcomponents that you can use to make the model self-documenting. So Insight Maker is a very powerful tool, and I'm sure it's one that Jeff could comment on. Roberto might also, if you could raise your hand, Roberto, you can also, you might also be able to comment on it. And it's one that supports very visual interaction. But both of these tools are, Insight Maker is one that you can share with others fairly readily, but at any one time, only one person can edit it. Another person can copy your model, sort of clone it and modify it, but it's really the province of one person to contribute to this, as I understand it.
In practice, that's the safest way to do it. You can actually have shared edits on a single model, but it's not. You find there are problems with the way it was designed. It's possible, but we tend not to do it.
Right, but it does lend itself to easy sharing for visualizing. This next tool that we'll be looking at is designed to address that next level of interactivity, and is designed to be used in a group modeling context, a context where multiple parties, say from a team or from a group in a room of experts, of co-located experts, or experts from around the world, from down under and up above, are brought together to address issues of common interest. And this tool is, it does come from my group. Peter in the back here has been the latest standard bearer for the tool. And I'd like to provide you a bit of an introduction to it. Recognize that it's very much under development. It's not something which is a finished tool. And this is very much an alpha version that we're looking at right now. And in order to see this, I would invite you to go to this following address: www.tinyurl.com.
Yes.
Actually, before they do that,
Okay.
they would have to go to the website to allow authentication.
Okay, CQHM.
Right, it's CQH.
Okay, go. If you could go to cqhm.usask.ca. Okay. And if you do go to that, they would need to, Peter, how would they get it to allow them to authenticate themselves?
Right, so, do you mind?
Yes, sure. Yeah.
So if all of you did manage to go to the website, now this is already logged in.
Okay.
So I would just temporarily log you out and then to show them.
Actually, no. Let's use don't. Well, okay, that's fine.
Or
So
you can do it incognito.
sign out. Yeah. Okay. Fine.
So
yeah, that's fine.
if you
I
go
was going to
to
do an incognito.
right. So if you go to the website, what you should see is something like this.
Do you see something like that?
Yes.
Okay.
And for those of you who are first time going to this and logging in, you should see something like, especially if you're using Chrome, they will see something like a pop-up blocked on this top right corner of the URL. Those of you who are using Firefox, I think you will have underneath the toolbar or bookmark bar, there will be a warning, and then there's a preference here. You can change also warning of a pop-up. Did you see that?
Yes.
Did you? So if you click on that, which shows here, and then just click on always allow pop-up from the website.
Okay.
Right.
So, Alex, maybe you could summon the phalanx of TAs. Who hopefully are outside, standing
So,
standing on guard for us.
Right.
Okay.
I think I will still do an incognito one just
Okay,
to.
who needs TA help for this? Okay, okay, who needs TA help? Okay, hands are raised. Sector 2. Who else would need help enabling pop-ups?
So this will be I think should be exactly what you see, and if you click on that, go to always allow pop-ups.
Always allow pop-ups from
that, and do a done. And what you want to do is click that again. Click the link it shows. Does all of you see that? Anyone that doesn't, you could raise your hand and
Yeah, does
ask
anyone
them.
not see it? The TAs stand ready to help.
Right. So if you click on that, unfortunately, since it's supported by Google API, you would have to have a Google account,
Gmail
or
account
Gmail account.
or a Google account.
Like, to use
Anything
it.
you use to access Google services.
Right.
Like Google Docs or Google Sheets or Gmail or Google Calendar or Contacts, anything you use for that. So if any of you are left without such and you'd like to see it, you can follow along. We'll be walking through it. But otherwise, if you do have that and could enter that information, that would allow you to log in.
Right.
Is that correct?
Right. Do you mind just do a quick login here? Or maybe I'll just switch back to the.
Yeah, switch back to
Right.
mine. Yeah.
Right. So as you log in, did you log in that pop-up window, and hit like something logging? So now after that, you want to click the login button here. It's either gonna just automatically log in since you already allowed the pop-up button, or some of them will not. You will have to type your information again.
Okay. So then they do this.
Right.
Okay. This is a one-time thing. Oh, okay.
This is a one-time thing.
Okay, and this is because I'm in incognito.
Right.
Okay. So I can go back to mine, right? This
Right.
is my normal window,
Right.
and I can just do login. Okay. And here I'm happy. Okay. Okay. So then I can go to dashboard.
Right. I just want to make sure. Did everyone get to a page something like that?
Yeah.
Anyone who didn't?
Who needs TA help? Kurt's on the prowl. Young Chin stands ready.
Okay. So if not, in that case, so that's done. You can now go to that link.
Okay.
The tiny URL.
Okay, so tinyurl.com/CQHM test2.
Right.
Okay?
Yep.
Okay.
Now, since you are the creator of the document,
My experience will be a bit different.
you will be directly going to the model.
Okay. What will they see?
They will see. Well, actually, it'll be the same. Yeah.
Okay.
Yeah. Sorry, I just remembered.
In an open.
Right. Did anyone see this this window?
So this is a one-time process you got to go through of sort of
Like for setting up,
Yeah,
yes. But
for setting up, yeah.
every time when you share the link,
Yeah.
you open it, they will show this.
Okay. Yeah. Okay.
So you have to click allow, right?
Right.
And all that's going to do is that's going to, oh, we've got it. I'm asking you for everyone.
Okay. Okay.
So do you see a window like this with the connected app, or does any of you don't see that connected app that's missing on mine?
Okay, so a couple TAs needed. The front sector 2, rows 1 and 2. Okay, can we summon reinforcements?
And of those who didn't see it, how many are using Mac?
We've seen the same as that.
Okay.
Okay, sector 3. Michael,
so
you need
those
help?
of you who are missing,
Oh.
You're not seeing the.
That wasn't the question.
Okay.
It was how many using Mac? And I've got my-
Okay. Are you encountering dysfunction?
Well, we're seeing no preview available.
right? So without connected app, right?
There's nothing at the top middle.
Right.
Okay.
So did all of you in this interface logged into a Google account yet?
Yeah.
In that case, you'll be fine. All you have to do is go to the cqhm.usas.ca, and you will see
A dashboard.
a dashboard like this and having a file name.
Okay.
Do you see that?
Yes.
So for those of you who didn't see a recommendation of connected app.
So if you got stuck at this and there's no connected app listed, then you can just go here and do it.
Because that's
If there is a connected app listed, then
they can just click that to go to the.
to go directly.
That's because they're using either Safari or.
I see.
So
Okay.
basically not.
Okay. Okay.
But,
Okay.
Yeah.
Okay.
As soon as they get the link and they got the access.
Right. Okay. So we'll obviously have to enormously simplify that. Okay.
So.
Okay. Who needs TA help here? No. Okay. So apologies. This is a one-time thing to access, to sort of learn how to access to do the pop-ups, so that it can access it and to log in. It should only be a one-time thing, I think.
Right,
Yeah.
login would be.
Login one
If you
time.
remember it will put it into a Google account.
Right.
Yeah.
Okay. Yes.
From the dashboard that you have the document, what's next?
Okay,
Oh,
you-
you will click on the document.
Yeah, here, I'll go back to it. So you'll click on this document here,
Right, just click on that.
and it should come up with
Right.
this.
Just wait, give it a.
It's on a Mac though. You said there was
Okay, so
click on dashboard.
click on the document there, yeah, yeah. So what do you see?
It tells me you are logging in but have not selected a model.
Okay, okay,
That's what we're seeing here, yeah.
okay, okay. So I think what you're seeing is, yeah, thanks Maria. You're seeing this, right?
Yes.
Yeah, okay. Okay, so Peter, it sounds like Peter's working to get this, the kinks out here. I'm going to go back to dashboard. When I do that, it switches over. It shows that for a moment and then switches, but. And that worked? Oh, okay, okay. That's interesting. Okay, so we may just have to.
For now, yeah, I will try to figure out that. It seems like a problem with Safari browsing to figure it out.
Okay, because Maria's using Chrome. It's also happening.
This is Chrome also. on yours.
Yeah.
Right.
Okay. Okay. So I'm going to have to ask people's apologies. I noted this was in alpha. It sounds like for some people they're not seeing this. Are some people seeing this on your computers?
Most people are.
Good. Okay.
So
Okay. Yes.
I guess for those who didn't see it, they can view the screen for now. I will try to figure out
Good.
some particular computer.
Great. Okay, so ladies and gentlemen, you should see a diagram. Do you see this diagram? Okay. The important thing here, the distinguishing feature of this system, is that it's a shared experience. So, for example, okay, someone's hard at work there. That's great. I encourage controlled frobbing behavior. So we can drag in, for example, to this person, this state chart entry point. We could give it a name here. So diabetes state chart here, and for example, add in a state and connect this up to the state. We'll have a state of normal glycemic here, normoglycemic. Are you folks seeing these changes? Okay. Now you folks can contribute as well. I mean, if you want to start dragging things in as well, you can do so. That's the power of this. Where it's designed to sort of allow multiple contributors at the same time to contribute to the emerging diagram. Okay, so this is an interesting aspect of dysfunction here. Okay, and here we'll drag this down. Okay. Okay, is someone dragging my transition? Okay, it's bouncing around. Okay, I'll add in another state. Let's be hopeful. Thank you, whoever is trying that. So pre-diabetic, and yet another state here associated with diabetic. Let's see. There we go. And we'll try this with diabetic. And then we'll try to drag some transitions between these. So here we go. Okay, yeah, this is great. I appreciate your help. Let's try one more swack at this guy. Okay, well, it's hopeful so far. Hey, there we go. The dream of centuries. Okay, this is great. We'll call this developing pre-diabetes, or we'll call it pre-diabetes incidence. Okay, there's a curious state chart entry point that's, okay, thanks. Whoever's cleaning that up, I appreciate your efforts. Okay, and this we'll call diabetes incidence. You'll notice that I'm using lowercase for the transitions. Diabetes incidence. That's sort of our tradition to sort of distinguish them. Now, one thing you'll notice is that right now we've placed this in this representation of an agent, but we actually haven't, they're not fully embedded in it. We can still move this agent separately. Peter is attempting by the end of this week to get these things fully contained so we can drag this agent shape around and these things will be embedded within it so we could sort of capture that nesting in a more natural way. So we may wish to do that. We may wish to also add aspects of parameters here. So we're going to go up to the agent palette and we're going to add in a parameter, for example, associated with perhaps. Thank you. Here associated with birth date. We might also have a parameter associated with their ethnicity, for example, or urban rural. Let's say ethnicity. These are characteristics of the individual that we might posit for that individual, and perhaps another for their income. For the sake of this model, we might simply represent their income as a static quantity. Because it befits the scope of the model rather than representing it in terms of dynamics. So here we have a way of capturing the fact that a given agent is associated with certain parameters, encoding assumptions, and further that they're associated with given changes. We could further associate them with stocks and flows. So perhaps we have a stock associated with their level of allostatic load, and flow into that associated with toxic stress. So here we'll connect it up. Okay, it is connected. Okay, great. And this will be, toxic stress is contributing to allostatic load here. So we could have stocks and flows associated with this agent. So this system is designed to allow many people simultaneously to contribute to an emerging diagram, to rename things, to add in new pieces, to structure it. And as you can see, this is a very early in terms of the functionality. There's a lot to be worked out. But the hope would be that we could use this in group model building sessions or team contexts where many parties want to share representation model and contribute to it over time. And where understanding might be refined by multiple parties. Eventually we want to capture notes, a full audit trail, who added what, stories behind particular links or loads or references as to where the evidence might be related to that, why you believe there's a connection between A and B, and to support this in a context of hybrid modeling. You'll notice that it does support these sort of causal links. They are incompletely supported now, but we might, for example, posit that toxic stress is affected by a person's socioeconomic position. And so we'll have a link from socioeconomic position to toxic stress. There are things, issues of sort of background and foreground, and we can sort of change the ordering of things to make sure that things are at the appropriate levels. But we're designing this to be able to build up causal diagrams, stocks and flows, state charts in a group context, and to allow for more fulsome sharing of these sort of models in a way that invites contribution. It's notable that you can contribute to this regardless of where you are in the world. If you're in the same room, you're in different rooms, you could have simultaneous connection via Skype or Hangouts or phone, and have an emerging kind of vision that can be captured by a model like this. Very early in its conception, it's got some rough edges now. Peter's going to be working in the course of the week to expand it further. We're hoping maybe within a year to support multiple languages, be able to convert a language, a model, allow it to be represented in English and also in French, or in English and Chinese, the same basic model, as well as to capture some of these aspects of kind of the thinking behind particular links, who added them, and maybe stories, audio or written. So this is going some places. The initial setup of it did require some futzing. Hopefully, now that you've gone through that, you'll be able to access it on a more regular basis. Okay? So this is where we're going: collaborative, qualitative, hybrid modeling, CQHM. And Peter's the person to talk to if you have particular needs that you'd like to see incorporated into that. Okay. Any questions about any of these three tools before we transition to a bit of hands-on work? Yes, Michael.
So it's gone to 8.1 logic, any logic,
Yeah.
which I assume is something to do with the cloud sharing. Do you want to just speak about that?
Sure. If anyone could get me a bit of tea, that'd be wonderful. Thanks so much. So AnyLogic as a platform evolves rather quickly at a high level. Version 6 introduced a lot of a very strong functionality, made creation of models easier for less technical people. Model 7 brought a wide variety of features associated with GIS and the use of databases. AnyLogic 8, some of its most important features, as you say, are centered around cloud computing. And the idea here, thanks enormously, the idea here is that when we run these models, particularly for agent-based and discrete event models, there's a substantive computational demand associated with running them. And that demand is reflective of two major needs. One of the needs is that, two major and one important but somewhat secondary needs. the two major needs are, number one, with these individual-based modeling traditions, agent-based and discrete event modeling are both characterized by the fact they characterize individuals at an individual level within a population. Right? They're not characterizing the count of people who are susceptible, the count that are exposed, count are infected, and simply keeping track as that rises and falls. The running time of such a model is independent of the size. But rather, once you're distinguishing particular individuals, if you double the number of individuals represented, it at least doubles, and often more than that, the running time of the model. So when we're dealing with large populations, perhaps you're characterizing screening for lung cancer within the population, you're dealing with hundreds of thousands of individuals, that can impose quite a load on your population, on your model rather, and running it. The second big load for both of those types of models, and for some system dynamics models, those incorporating stochastics, comes from the fact that the models need to be run many, many times to come to firm understanding for a given set of assumptions or parameters. Because in the presence of stochastics, a given run, the results from a given run could be a fluke. It could be a happenstance of chance. But by running it many times, we get a distribution which gives us confidence as to what the regularities are. That okay, this intervention leads to generally higher cost effectiveness than this other, or leads to higher health outcomes than this other one. But the distributions overlap a bit, but it's tight enough that we think this one is by and large much better than this other. Or it lets us compute an average outcome that's more reliable statistically. And we end up using a large number of non-parametric tests and so on to compare outcomes. But in terms of computational load, you've got to run it many times. Maybe it's 50 times, maybe it's 100 times. And each of those runs involves simulating the model in its entirety from start to finish. So that too is a contribution of computational load. The third area is one associated when often when we run these models, we run what are called sensitivity analyses or calibrations, which involve running the model with different assumptions and seeing its response. And those two are different from each other. We'll cover them later in the week. But with a sensitivity analysis, you're running the model, with this set of assumptions, with that one, for often in a very sort of a systematic way, sometimes with respect to multiple parameters at once. So you might be running the model 100 times, and for each of those 100 times, you run it 100 times to capture the effects of stochastics, and each of those runs is substantive because it involves a big population. That's a big load. You can run it on your computer. The computers are in front of you, like the TAs who glide through the room, are associated with strong computational processing power and great capabilities. And I'm sure your laptop is also recommended by multiple cores to run these systems on. And AnyLogic takes advantage of that. If you're running it on one computer, it will try to run things in parallel. If you have 4 cores, it can mean 4 versions of AnyLogic, 4 sort of instances running at the same time. But there's a limit to that. And the cloud out there, the sort of collection of utility services, things that we can run on almost as commodities. We can use computational power like a commodity, just as we can plug into a wall outlet and get electricity. The cloud allows us to tap on demand in an interchangeable way computational services. So AnyLogic 8.1, and we'll do a demonstration later in the week where this functionality is supported, can allow you to basically take advantage of running a model in parallel for those 2 latter types of computational needs I noted. Number 1, you're running the model many, many realizations to get statistical reliability. Number 2, you're running the model many times over for different assumptions about parameters in calibration or in optimization. you can perform that, particularly for the sensitivity analysis case, I should say. That's something that you can perform in parallel on the cloud. And what that means is you may harness, bend to your will, 1,000 computers. What is it, Daphne launched, it was the face that launched 1,000 ships? Jeff would know this. Helen of Troy, thank you. That Michael, you can launch 1,000 computers undertaking simulations on your same model with perhaps 1,000 running different parameter variations, and within that 1,000 running different realizations. And something that might take you a month of time to simulate on your own computer could be done in a matter of a few hours. That's the promise of the cloud, that we can make use of these computational resources. Windchill, who's one of the most experienced and advanced people, could speak with some fulsomeness about the use of cloud computing. We've made extensive use of this in this very building with some of the machines that surround us. We'll make use of them, simultaneously processing them and running models in parallel with any logic over these large sets of machines. And it really does afford us a very rapid ability to accelerate our computations. Wade, who also has benefited the room with his presence within the past hour here, and I believe is yet outside. He's also done a large amount of this parallel computing. And if anyone's interested, we could talk about that in more depth. But there's something, Michael, that it does not do. There's something that's an easy misconception, that we might have cherished hopes, but where it falls flat. And that is, we can't run a given run of a simulation over time in parallel. There's not a way to break up this set of agents is on this computer, that set of agents is on that computer. That is a problem that any logic hasn't yet addressed through parallel computing. So a given run of it, if a given run takes an hour, you can harness all the machines in the world, and it's still going to take an hour to run, minimum. But you could run 1,000 or 1,000,000 simulations in that hour rather than just one. That is something that you can use. We can, in short, harness to the yoke of armies of machines, flotillas like that launched to attack Troy by Helen's beckoning face. We can launch similar armadas computationally using the tools to take on these what are called embarrassingly parallel problems. And those embarrassingly parallel problems are what these cloud-based services with AnyLogic allows us to harness. And we'll see if we can have a little session of show and tell where that can be demonstrated. I should note, just while we're at it, that tomorrow night in this very room and on this floor, we'll be having a show and tell. We'll be having a poster session of sorts where the students who sit amongst us and those yet outside will demonstrate some of the various projects they've been working on. And you can learn a little bit more about some of these items by engaging in discussion with the students in a similar way you would to a poster session at a conference. And that will give a little bit more diversity to some of the topics we'll hit with the boot camp. So tomorrow night is our poster session, and we'll see if we can cater food. Well, we are catering food for it, so you can browse those models while simultaneously satisfying your mind and your stomach. Okay? So that's tomorrow night, and it's possible that one of the students will speak tomorrow night about this cloud-based use. If not, we'll be sure to feature it in a plenary session or at least a parallel session later in the week. Is that helpful? Yeah.
Thanks very much.
Okay, very good. Okay, other questions?
I have a question on the software.
Yes.
Is there other software? Because to get all the capabilities of this,
Yeah.
it's pretty expensive, right? Is there anything that would work comparable
Yeah.
Listed a degree or-
Yeah, that's a great question. I could prioritize the topic I was going to leave for the last day, which but I can move it up, which has to do with number one, different software packages. So our group has made use of everything from ModGen to Repast to NetLogo to AnyLogic to Vensim. As well as Alex, who has been in most of the day, but seeks refuge from the room at the moment, I guess. Alex has been very active in crafting a new language. We have our own modeling platform that we're building up that we hope to use to capture many of the advantages of AnyLogic, but in a freeware way and open source, but to have many more advantages yet, including integration with computational statistics, machine learning, collaborative modeling of the sort that you've just seen, to build in data feeds and to support richer parallelization opportunities, etc. We're working at that, but there are a number of other packages that we can talk about, and I'm glad to do so. And speak from direct experience with them and their trade-offs. Also with AnyLogic, there's several different versions which carry very different price points. And I'd like to talk some about the trade-off between those versions. Scott here, who I believe is somewhere outside, has also can speak to the different versioning issues, both in their details and in the pricing. So we can do that. Scott is left for the day.
He'll be back tomorrow.
Okay, thank you very much, Christine. Okay, so other questions? Questions? Okay, I think what we'll do now, if we can, is we're going to turn to a first little bit of model building within AnyLogic. Okay, I'd like to try building up a model with you interactively that illustrates some of the basic features of the platform, specifically when it comes to assumptions within the model. So this poverty causal loop diagram, I'd like to close that, and I'd like to start with a new model here. Okay, this model will be called heterogeneous population. I'll call it population heterogeneity. And we're going to choose the time unit associated with the model carefully to be years here, okay? We aren't going to depend on that very, very heavily, but we do want it to be phrased for a longer time frame. Okay. So with this model, we're going to have our first experience building up a little model that captures some features of a population, and it will illustrate some of the ways in which we capture heterogeneity in nested population structure within AnyLogic. I'm going to